So, how can I introduce this question? This question was on the news. It was such a tricky one, and we are going to go through it. Hopefully, you've given it a go. Yeah, let's get started. So, I would say, first thing to do, label the peaks. So, A, B, C, D, E. Brilliant. Now, this question is unusual because they give you part of the structure here. So, what we have to do, or what I think would make it easier, is to match the protons from the structure to the spectrum. For example, we have here 3 hydrogens on the benzene ring, so you would expect a peak of area 3 and a ppm around 7. So that will be this peak here. But as you can see, you have 2 peaks, but they only give you one area value, which is 7. So that suggests that there are 2 benzene rings, one with area 3, one with area 4, which is quite tricky. The other hydrogen we can see is bonded to a nitrogen, would be area 1, and because it's bonded to nitrogen, it is a singlet. So that definitely is going to be peak D. So we can remove now peak D from the spectrum. It's already analyzed. So the next bit is the area. Area 3 methyl, area 2 CH2, and then area 7, as we said before, a benzene ring with 4 hydrogens and another one with 3. Okay, so now let's do the splitting pattern. So for peak A, it's a triplet, so adjacent to CH2. Peak B, bonded to a blocking group, I call it, so maybe a benzene ring, a C double bond O, a nitrogen, an oxygen. Peak C is a quartet, so next to a CH3. And then for the benzene ring, we cannot interpret the splitting pattern in A level chemistry. Okay, so we are now getting some pieces of the puzzle. Let's look at the type of proton now. So peak A would fall in this range, which is what we expected, CH3, CH2. Forgot to say, but I'll say now. This CH2 has to be peak C. It's the only CH2 that we have, and actually, we see that CH2 is also adjacent to a CH3. That has to be A. Fine, so now for peak B, they tell us that this peak at 1.6, between 1.6 and 2.2, is a hydrogen bonded to a carbon with a double bond nitrogen. Carbon double bond nitrogen is here. So that means that peak B, which is a methyl, is a CH3 bonded to that carbon, which means that R1 or R2, doesn't matter, is going to be a methyl group. Right, and then for peak E, we know it's a benzene ring. So now if we try to put all this information together, what we have is that A is next to C. I forgot to say, sorry, for peak B, you can have 2 options, this one or this one. It could also be a hydrogen bonded to a carbon bonded to a nitrogen, but you would expect the nitrogen to have some hydrogens, which would produce additional peaks. So it's going to be one of these 2. So then you try both options, yeah? You try the carbonite and then the benzene ring, that is substituted, or just straight away this option without the C double bond O. Pause the video and think, how can you determine which structure is the right one? Right, so if you remember at the very beginning of the video, I can promise you, the question said there were 14 peaks in the carbon NMR spectrum. So this one will have one more peak than this one. Let's count how many peaks. 1, 2, that one 3, 4, 5. And this has as well 4, 5 due to symmetry, 6, 7, 8, and then 9, 10, 11, 12, 13, and that would be 14. So that's the right structure.